Hi everyone. On this lesson we're going to be simplifying complex fractions. So before we get to the actual lesson, I'm just going to show you an example. This would be a complex fraction, right? Because it's a fraction divided by a fraction. So technically what's happening here is we can take 7/8 divided by 3/16. And remember, when we're dividing, we actually rewrite that as multiplication, so it's going to be times 16/3. And then at this point we're going to simplify what we can. Now I'm going to show you a couple of different techniques, but for the simplifying part is just like we did on previous lessons. So you can see that 8 goes into 16 two times and 8 goes into itself one time. If I multiply, then I get 14/3, and then that's considered simplified. All right, so we took this complex fraction and we end up with just a normal fraction in the end. Sometimes, depending on the type of question, the answer it won't be a fraction answer, for instance. So it can look different depending on what we started with. Okay, so there are two methods in this section. On the first method, I basically prefer that we just perform this method when we already have a fraction divided by a fraction. So in other words, we don't have two fractions in the numerator, or we don't have two fractions in the denominator. We just have one fraction divided by one fraction. And so notice it says simplify the numerator and denominator of the complex fraction so that each is a single fraction if needed. Well, for this method, I would suggest you just use it when you already have a fraction divided by another fraction. Okay, so if I rewrite this, notice it says perform the indicated division by multiplying the numerator of the complex fraction by the reciprocal of the denominator. So I'm going to go ahead and write it as division first for this question. So it's going to be 15/2x divided by 5/6x. Well, if I rewrite that as multiplication, then I have 15/2x times 6x/5. Now, these are pretty simple numbers here, so you can see, and we only have an x in the numerator and denominator. So I'm just going to simplify by common factors, right? 2x goes into 6x 3 times, and 5 goes into 15 3 times. And notice I just have 1 in my denominator, so I end up with an answer of 9. So that's where we ended up with this particular complex fraction, that it simplifies just to a 9. Okay, let's look at the next one. So now I'm going to use the information that was given to you about method 1, right? If I take the numerator, x over x plus 2, and I multiply it by the reciprocal of the denominator. Remember, the reciprocal means that we're going to flip it, right, upside down, because that's the definition of reciprocals, right? It's going to be whatever that was upside down from where we started. So like the reciprocal of 2/3 is 3/2. One of the definitions of reciprocals is that if I multiply reciprocals, I always get 1. And so you can see that would happen with 2/3 times 3/2. So what's in common? Well, we have the x plus 2. All right, and so this one simplifies to x over 2. And that's it for that one. Remember, this is when it's a fraction, one fraction over one fraction. Okay, you'll see what I'm talking about when we get to some of the other ones in a minute. So let's go to this next one. I have x plus 3 over 12. Now I'm going to multiply by the reciprocal of that denominator. So 15/4x minus 5. Then I'm going to see, okay, what can I simplify here? Well, you see that 12 and 15 have a common factor, But x plus 3 and 4x minus 5 do not have a common factor, so those two I can't factor or simplify at all. All right, so on this next one, I'm going to divide both of these by 3. So 3 goes into 12 4 times, 3 goes into 15 5 times, and my answer is 5 times x plus 3. You don't have to multiply that back out. You can just leave it like it is, over 4 times 4x minus 5. And so sometimes your answers are not going to look very simple, but you won't have two fractions, right? We don't have a fraction in the numerator and a fraction in the denominator once it's simplified. Okay, so that's it for that one, and that was method 1. Now we're going to go to method 2. And it's really nice to understand both of these, because method 1 is easy if you just have two fractions. But method 2, I prefer when you have more than a fraction in the numerator and denominator. Notice in our denominator, we have 1 over y minus 3 over x. Now, the way that we simplify this is we multiply the numerator and the denominator by the LCD of all the fractions in the numerator or denominator. So let's kind of examine that. We have this denominator of x times y. This fraction has a y, this fraction has an x. And so you can see that if we use the method I've talked to you about, I circle the xy, and then I say, are there any other factors in any of my fractions that I haven't circled? And there aren't, right? Because I have a y and an x in my denominator. So my LCD will simply be x times y. Okay, so now I'm going to multiply everything, right? All three fractions by xy. Usually I just write it beside each one because I feel like that is going to be the easier technique. So I'm going to say times xy. This one is times xy. This is times xy. So every fraction in the entire question in the complex fraction must be multiplied by the xy. Okay, so what happens is I eliminate this denominator, and that is the point, you guys. You should be getting rid of your denominators, because xy divided by xy is 1. All right, so all I have left in my numerator of the complex fraction was x squared minus 9y squared. And then for the next part, I'm going to say, all right, y goes into y one time. So now I've eliminated the y, and then I take x times 1, right? So I'm going to multiply the x times 1, so that just leaves me with an x. X goes into xy, and this just leaves me with a y, so I'm going to multiply 3 times y, so that's going to be x minus 3y. Now we have a little bit more to do here, because you can see that this numerator is the difference of two squares. And so we're going to be able to factor the difference of two squares. And so let's see, I think I can fit it here below. I'm going to have x minus 3y times x plus 3y. And remember, the difference of squares is something that you just learn to recognize. So that is going to mean we can eliminate what equals 1, right? X minus 3 over x minus 3 is 1. And so my answer is x plus 3y. All right. And so that's it for that particular question. It's simplified as far as we can go. All right. So let's see, 1, 2, 3, 4, 5. I think I'm going to stop the video here, and then I'll pick up with this slide on the next video.